All right. In our previous class, we treated inorganic chemistry. So hopefully today we are dealing on heat energy. Okay. And we are actually going to start from the beginning of it. Although everything that we are going to be doing today is going to be based on calculations. Okay. We are starting from temperature conversions. Okay. Even at the tutorial, we are still in chapter 1 of this textbook. Okay. So what I'm going to do now, I'll bring out the formula for temperature conversion. I will see how we'll be able to what to solve one or two questions in it. Okay. All right. Now, for temperature conversion, now when it comes to temperature conversion, okay, in a thermometer, we have the upper fixed point of a thermometer. We have the upper fixed point, and we also have the lower fixed point. Now, our upper fixed point is also known as steam point, or you can also call it the boiling point. Then while the lower fixed point is also known as the ice point, or you can call it the melting point. So our upper fixed point is the temperature of pure boiling water, okay, at standard atmospheric pressure of 760 millimeter mercury. While the lower fixed point is the temperature of pure melting ice, okay, at standard atmospheric pressure of 760 millimeter mercury. So when it now comes to fundamental interval, it is the temperature difference, okay, between the upper and the lower fixed point of the word of a thermometer. Okay, so that's why if you have a thermometer scale, okay, this very place is known as your upper fixed point. Your upper fixed point. Okay. Then while the damper is known as the lower fixed point. Okay, this very place here is known as the fundamental interval of a thermometer. Now, but before we go into all of this, okay, first of all, like I said, now we have different types of scale, temperature thermometer scale. Okay, we have about 5 types of scale, temperature scale. So we have the Celsius scale. Which is also known as what degree centigrade. So it's measured in degree Celsius. Then we also have the Fahrenheit scale. Okay, we call it degree Fahrenheit. So we also have the Kelvin scale. Either you call it Kelvin, either you call it Kelvin, you can call it absolute, or you can call it thermodynamic scale. Now, our Kelvin scale is measured in what? In Kelvin. There's nothing like degree what? There's nothing like degree Kelvin. Okay, so the next one there, okay, is the Rankine scale. The Rankine scale. Okay, that is our degree Rankine. And the last one there is the what? The Raman scale. Okay, we call it degree Raman. Okay, now these are the various types of scales that we have. So based on your level, we are going to be focusing more on the Celsius scale, the Fahrenheit scale, and the what? And the Kelvin scale. So I'm going to give you the relationship, okay, between the Celsius and the Fahrenheit, and I will also give you the relationship between Fahrenheit and Kelvin. Okay, so we are going to do some proving as well. Okay, now from here, now relationship between Kelvin and Celsius scale. So we have Kelvin equals to 273.15 plus degree Celsius. Now this is the relationship between the Kelvin and degree Celsius. Please take note, this is heat energy. Okay, although that's the actual value, okay, which is 273.15. Now, when it comes to degree Celsius, the lower fixed point is 273 and the upper fixed point is 373. Okay, so we are using 1.1. If you approximate, you still have 273. So in your GLT, okay, you are going to be making use of what 273. Okay, you don't use 0.15. Okay, so this relationship between Kelvin and degree Celsius. So we also have relationship between degree Celsius and Fahrenheit. So we have degree Celsius equals to 5 bracket degree Fahrenheit minus 32 then all over 9. Okay, now this one is the relationship between degree Celsius and Fahrenheit. Don't worry, we are going to prove this formula. So we also have so with these two, you should be able to prove the relationship between Kelvin and degree what Celsius. But first of all, let's prove this relationship, okay? Because you might see it in your exam. All right. Now, please take note of this. Now, you can just write GLT here, okay? So in your GLT exam, okay, which is General Laboratory Techniques 111, they are going to ask you to prove the relationship between Fahrenheit, okay, and Kelvin. Or they'll ask you show the formula, show the formula that link, show the formula that link Kelvin and degree Fahrenheit. Show the formula that link Kelvin and what? And degree Fahrenheit. Okay. All right. Now, to prove this is very easy. What you are going to do, you introduce the formula that relates degree Celsius, okay, and Kelvin. Now, our K is equals to 273, okay, plus what? Degree Celsius. Now, what you do, you make degree Celsius the subject of the formula. So if your 273 is crossing over to this side, become minus. So at the end, we have K minus 273 then equals to degree Celsius. We give us degree Celsius equals to K minus 273. What you do, you call this equation 1. Then we also have a relationship which I give to you just now between degree Celsius and Fahrenheit. So we have degree Celsius equals to 5 bracket degree Fahrenheit minus 32 then all over 9. Okay, now you can call this equation 2. So what you are going to do here, you substitute equation 1 into equation 2 or equation 2 into equation 1. Okay, now this time around, we'll put equation 1 into 2. Okay, what does it mean? Our equation 2 here is degree Celsius equals to 5 bracket degree Fahrenheit minus 32 all over 9. It simply means that anywhere you see degree Celsius, here what's our degree Celsius? Degree Celsius is sitting as K minus 273. So anywhere you see degree Celsius here, you are going to replace it with what? K minus 273. At the end, our degree Celsius here is sitting as well K minus 273. Okay, then equals to 5 bracket degree Fahrenheit minus 32 then all over 9. So what do you do here? Okay, you can open this bracket. So we have K minus 273 equals to 5 times degree Fahrenheit. We have 5 degree Fahrenheit. And 5 times minus 32, we have minus 160. Then all over 9. So what do you do here? You cross multiply. Once we cross multiply, we have 9 bracket K minus 273. Then equals to 5 degree Fahrenheit minus 160. So what do you do here? We use this 9 to open on the bracket. So 9 times K, we have 9K. Then 9 times minus 273. So 9 times 273. 9 times minus 273. So we have minus 2457. Minus 24, then 57 equals to 5 degree Fahrenheit minus 160. So we want to make our K the subject of the formula. And to do that, what happened? So our minus 24757 will cross over to the what? To the right hand side. And once it's crossing over, what happened? The minus sign changed to what? Changed to plus. So this time around, we're going to have, so we are going to have 9K equals to 5 degree Fahrenheit minus 160. So if it's crossing over, it becomes plus 270. Sorry, plus 2457. Plus 2457. So we have 9K equals to 5 degree Fahrenheit minus 160 plus 2457 minus 160 plus 2457. So we are going to have plus 2297. So to make K the square of the formula, I'll divide both sides by 9. So our K will be equal to 5 degree Fahrenheit plus 2297, then all over 9. So this one is the relationship, okay? You can call it equation 3. So this is the relationship between Kelvin and degree Fahrenheit. So what I'm going to do now, I'm going to write out all the formulas here, okay? Remember, this for GLT, you'll be asking your exam. So yeah, our K, I gave you K equals to 273.15 plus degree Celsius. Okay, this is energy. But when it comes to GLT, it becomes just 27.3. Okay, so point what? 15. So I also gave you degree Celsius equals to 5 bracket degree Fahrenheit minus 32, then all over 9. So I also gave you now that K is equal to 5 degree Fahrenheit plus 2297 all over 9. So please take note of these formulas. Okay, so what I'm going to do, I'm also going to prove this very word equation because you also be asking your exam. Now to prove that is very easy. Okay, they'll ask you, they'll ask you in your heat energy, show that degree Celsius equals to 5 bracket degree Fahrenheit minus 32 all over 9. How do you do this? To prove this formula, you make use of what is called extrapolation method. Extrapolation method. Now, extrapolation method deal with what? Two scales, two temperature scales. Now, in using extrapolation method, this is how to go about it. So we have this and we have this. So this temperature scale is for degree Celsius, while this is for degree Fahrenheit. Now, when it comes to degree Celsius, our upper fixed point is 100, okay? Then our lower fixed point is what? Is 0. Then in terms of Kelvin, for degree Kelvin, okay, upper fixed point is 373, and lower fixed point is what? 273. Okay, this for Kelvin. So this for what? Degree Celsius. For Fahrenheit, upper fixed point is 212 and lower fixed point is what? 32. Okay, now to prove this, you make use of this. Then remember, here is degree Celsius and here is degree Fahrenheit. So here is A, B, and C. You call here A1, call here B1, and call here what? C1. Now, this is how to go about it. Here we have A minus C all over B minus C equals to A1 minus B1 all over B1 minus C1. Now, what happened to this side is what is happening to this side. So this time around, our A here is sitting as 100. Then minus our C is what? 0. What's B? B is what? Degree Celsius minus what? 0. Then equals to A1 is what? 212 minus what's B1? 32. All over B1 is what? Degree Fahrenheit minus 32. So from here, 100 minus 0, we still have what? 100 all over degree Celsius minus 0, we have degree Celsius. Then equals to 212 minus 32. So we have 180. Then all over degree Fahrenheit minus 32. Okay, a variable cannot subtract what a value. So what do you do here? We cross multiply. So if we cross multiply, we are going to have 180 degrees Celsius, then equals to now 100 bracket degree Fahrenheit minus 32. So from here, since we are looking for degrees Celsius, what do? You divide both sides by what? 180. So our degree Celsius is equals to 100 bracket degree Fahrenheit minus 32, then all over 180. Now from here, what can go into this place? 20 can go, 5 can go. Now 20 into 100 is what? Is 5. And 20 into 180. 180 divided by 20, it gives us what? 9. So at the end, so therefore, our degree Celsius is going to give us 20 to 100, it gives us 5. And 20 here is what? 9. We have 5 bracket degree Fahrenheit minus 32, then all over 9. So that is how this other equation came about. Okay, so let's proceed. So this very one, you might be asking your heat energy exam. Okay, now so we are going to be using this equation to be solving now. Okay, we are still on temperature conversion. Now let's take these questions. Express number 1. Express 40 degrees Celsius in degree Fahrenheit. 40 degrees Celsius in degree Fahrenheit. Now, whenever you are given a question like this in your exam, what should come to your mind? Oh, this is the relationship between degree Celsius and degree Fahrenheit. What should come to your mind? It should be which formula? This is Kelvin and Celsius, and this is Celsius and Fahrenheit, and this is Kelvin and Fahrenheit. So the right equation to use is equation 2. Okay, so you can just go ahead. They are telling you here that your degree Celsius is setting as what? 40. Okay, now using that formula, we have degree Celsius equals to 5 brackets degree Fahrenheit minus 32 all over 9. You are asked to convert it to degree Fahrenheit. So what do you do here? Our degree Celsius is setting as what? 40. So this is setting as 40 equals to, so here we have 5 bracket, we are looking for degree Fahrenheit minus 32, then all over what? 9. So from here we have 40 equals to, use this 5 to open up the bracket. 5 times degree Fahrenheit, 5 degree Fahrenheit, and 5 times minus 32, we have minus 160, then all over 9. So what do you do here? You cross multiply. Now here we have 5 degree Fahrenheit minus 160 equals to 40 times 9. So 5 degree Fahrenheit minus 160 equals to 40 times 9. 40 times 9, it gives us 360. So from there, you collect like terms. So we have 5 degree Fahrenheit equals to 360. When this one is crossing over to the other side, we have plus 160. So we have 5 degree Fahrenheit equals to 360 plus 160. So 360 plus 160 is going to give us 520. So 520. Now to get our degree Fahrenheit, I will divide both sides by what? 5. So degree Fahrenheit equals to 520 divided by 5. And what are we going to have? We are going to have 104. So 104 degree Fahrenheit. So that is for that. So copy that and let's move to the next phase. So for the number 2 question, we will ask, express 313 Kelvin in degrees Celsius. 313 Kelvin in degree what? Celsius. All right. So from here, what relationship is this? This is the relationship between Kelvin and degree Celsius. So which formula are we to use? Is the first formula. Okay. So here we are told that our Kelvin is sitting at 313. Okay. So we have Kelvin equals to 273.15 plus degree Celsius. Okay. So from here, what's our Kelvin? Our Kelvin is sitting at 313. So here we have 313 equals to 273.15 plus degree Celsius. So once this is crossing over to the other side, become negative. So we have 313 minus 273.15 equals to degree Celsius. So our degree Celsius is going to give us 313 minus 273.15. 313 minus 273.15. So it's going to give us 39.85 degrees Celsius. So that is for that. So let's move straight to the next one. So number 3, we are told express 232 degree Fahrenheit in degrees Celsius. 232 degree Fahrenheit in degrees Celsius. So from here, what relationship is this? It's still relationship between Fahrenheit and Celsius, which is the second equation. So here, our degree Fahrenheit was going to be 232. So the formula is degree Celsius equals to 5 bracket degree Fahrenheit minus 32 all over 9. Okay, so here we are looking for degree Celsius. So degree Celsius equals to 5 bracket what degree Fahrenheit? 232. Then minus 32 all over 9. So degree Celsius equals to 5 bracket 232 minus 32, we have 200 all over 9. So degree Celsius equals to 5 times 200 will give us 1000 all over 9. And 1000 divided by 9, we are going to have 111.111111 what degree Celsius. Okay, so that is for that. So copy that. So let's move to the next one for question number 4. Express, okay, convert 45 degrees Celsius to Kelvin. All right, 45 degrees Celsius to Kelvin. Okay, so from here, our degree Celsius was going to be 45. Okay, now we have to convert to Kelvin. So the relationship between degree Celsius and Kelvin. So from here, our Kelvin is equals to 273.15, then plus degree Celsius. So we're going to have K equals to 273.15 plus what degree Celsius? That's 45. So our K will give us 273.15 plus 45. So we are going to have 318.15 Kelvin. So that is for that. Then number 5. Express 20 degrees Celsius in degree Fahrenheit. So this should be your assignment. Okay, so you can give this a try. 20 degrees Celsius in degree what? Fahrenheit. So we are also going to take some questions for this. Okay. So for that, we can take that as number 6. So ensure you try this number 5. So for number 6, if we are given a question that we should express or convert 212 Kelvin to degree Fahrenheit. Actually, you can solve this very question in 2 ways. You can solve it in 2 ways. Okay, I'm going to use the both way. But first of all, take note. If you know this formula of art, okay, you go straight to the answer. Okay, but if probably we are not able to remember this in your exam, so what you are going to do, since you are converting Kelvin to Fahrenheit, first of all, you have to convert this Kelvin first to degree Celsius. Once you convert it to degree Celsius using this formula, then from here you now substitute your degree Celsius that you got into this formula to get your degree Fahrenheit. You still arrive at the same word answer. So let's give it a try for the two formula. Using the first formula, okay, here we are told our Kelvin is equal to 212. Okay, so from here we are given K equals to 5 degree Fahrenheit plus 2297 all over 9. So yeah, our K was given to be what? 212 equals to 5 degree Fahrenheit plus 2297 all over 9. Okay, so from here, what do? We cross multiply. So we have 5 degree Fahrenheit plus 2297 equals to 212 times 9. So from here, we have 5 degree Fahrenheit plus 2297 equals to 212 times 9. 212 times 9. So we have 1908. What do?